Now, I was hesitant to show you Wireshark so early in the course, but it's important that I show you how things work with real devices. So I'm going to introduce it now. If you struggle with this video, don't worry, you can come back to it later. I'll also explain more details using packet trace in a moment, but I just want to show you what actually happens on a real Ethernet network. The application Wireshark is a packet analyzer or sniffer. It basically captures packets off the wire so that we can analyze them and see what's going on. It'll show us all the layers in the OSI model. What I'm going to do is open up a web browser on this computer to that server. So on that laptop, we're running a web server. I've shown you this previously in the course. But again, if I open IIS, Internet Information Services, this is a web server running on that laptop. So open this up and go to Sites, Default Site. What you'll notice under Bindings is that the port used is 80. Protocol is HTTP. So the server is listening on port 80. Again, you can see here, browse to port 80. So that'll browse to the website, but I'm not going to do it on the local computer. I'm going to do it on the client computer. So this laptop is acting as a server now, and that computer is going to be our client. So what I'll do on the client computer is run Wireshark. It's a free application that you can download. Just search for it on Google as an example. And what we'll be able to look for is traffic on a specific interface. Now we need to make sure that we are sniffing or looking at the correct interface. In this example, it's Ethernet 2 with IP address 192.168.1.2. So I'm going to double click on that, and that shows me a whole bunch of traffic. Again, don't get overwhelmed with what you see here. You'll see a whole bunch of traffic. Don't worry too much about it. What we're going to search for here is HTTP. So I am now filtering for HTTP, so we only see HTTP traffic. I'll open up a web browser. So Chrome in this example, and browse to 192.168.1.3. That's the IP address of the server. So back on the server, if I open up a command prompt and type the command ipconfig, you can see the IP address is 192.168.1.3. So back on the client, go to 192.168.1.3. What you'll notice is a website displays, and what you'll also see is traffic is now displayed in Wireshark. You can see an HTTP GET. Basically, the client is requesting information from the server. This is very similar to what we saw in Packet Tracer, but this is real world. So the frame we told is 578 bytes on the wire, 4,624 bits. That's the actual frame sent on the wire. So think of that as layer 1. So we've got layer 1 right there. Some information about layer 1 is displayed, but I'm going to close that and notice layer 2. Which encapsulation is used? It's Ethernet 2, most common type of Ethernet encapsulation that you'll find. We are using Ethernet interfaces here. So we're going to see Ethernet from a source MAC address of this. And notice half the MAC address means vendor code. Half is a unique identifier. So Wireshark knows that this is a Dell laptop because the vendor code, in other words, half that MAC address is the vendor code for Dell. And on the right-hand side, it says TP-Link. That's because I'm using a USB adapter in this computer. It's a TP-Link adapter. So there's the vendor code for TP-Link. There's the actual MAC address. So the traffic is going from this device to this device. Source MAC address is this. Destination MAC address is this. And what is used at layer 2 to indicate layer 3? Remember, it's the type field. So just like Packet Tracer, we know that the protocol used at layer 3 is IP version 4, and Wireshark fills that information in for us very nicely. So we can see at layer 2, it's Ethernet 2. At layer 3, it's going to be IP version 4. We can see that here. So opening this up, we can see IP version 4, Internet Protocol version 4, source IP address, destination IP address. So on this Dell computer, if I type ipconfig, you can see the IP address is 192.168.1.2. So this device is talking to the TP-Link device. Protocol is IP version 4. Again, lots of information here. Don't worry too much about it. But notice protocol field 6 for TCP. Wireshark tells us that this is TCP, so it makes it easy for us to understand. So we can see source and destination IP address, and the protocol used at layer 4 is TCP or Transmission Control Protocol, source port, destination port. Remember, this is an ephemeral or dynamic port number. Packet Tracer was using a number of 1026 in our example, greater than 1023. But remember, according to the IANA, this is the port range that should be used. Here are the port numbers again on the IANA, and we're told that dynamic or private port numbers or ephemeral port numbers are in that range, and that's what Windows 11 is using. So Windows 11 is following the most recent IANA recommendations. Older versions of Windows wouldn't necessarily have done that. So we've got a source port of 63,700 going to the server. An HTTP server listens by default on port 80, and we saw that on the server. On the server again, notice it's listening on port 80 because that's where it's bound, port 80. So the client is configured to send traffic to port 80 by default because we're using HTTP. So Chrome knows that. So the data will end up at the server that's expecting it listening on port 80. It's HTTP or Hypertext Transfer Protocol. There's a lot of information here. Again, don't worry about it. But notice here we can see that we're using Windows 64, x64 architecture. It's showing up as NT10. It's actually Windows 11. We can see that it's looking for information from the server. Now, what happens when the server replies? Server replies back here. Notice IP addresses are flipped around. So the server with IP address 192.168.1.3 is talking to 192.168.1.2. Port numbers have also flipped around. Source port is now 80. Destination port is our ephemeral or random or dynamic port number. And within HTTP, we're seeing some information. So we can see that it's a Microsoft IIS server. So notice MAC addresses are swapped around. Notice IP addresses are swapped around. Notice port numbers are swapped around. Again, the client dynamically chose this port number. It's an ephemeral port because it only lasts for a short period of time, hence that name ephemeral. This port number is only in use while we have the browser up. When we shut the browser, the port number changes. Now, what happens if we close it down and open it up again? Okay, this is interesting. It's actually chosen exactly the same port number. You would have thought that it would be random and chose a different port number, but it chose exactly the same port number. I'll open up a different session here, and notice here now, it's using a different port number, 63703. So 2 sessions, different port numbers. If I open up Edge, so a different browser now, and I go to 192.168.1.3, so same server, what we should see is that a different port number is used again. So here we see the port number is 63706. So different browser, different sessions. Each of those are ephemeral. They are remembered only for a short period of time. We saw how when I closed Chrome down and started up again, it actually used the same port number, which probably not a great idea. But there you go. Different port numbers for different sessions. So the source port numbers change, but notice the destination port number is always 80. The server is going to have a system to differentiate between the sessions, but it's listening on port 80 and receiving multiple connections from the clients. The clients are differentiating between the sessions based on the port numbers. I don't want to confuse you too much. I think that's enough to get started. What I want you to realize is that devices use MAC addresses at layer 2. They use IP addresses at layer 3 because we're using TCP IP, in this case IP version 4. They use either TCP or UDP generally, but other protocols do exist at layer 4. And then we have the layer 7 protocol. Notice how the 5-layer TCP IP model is used here. We've got layer 1, the bits on the wire. Layer 2, frames. Layer 3, packets. Layer 4, segments. Layer 5, our application protocol. This is real world. Hoping it helped you. Don't worry if it's a bit confusing. You'll learn a lot about Wireshark and how protocols work as we go through the course. I just wanted to show you real world physical devices versus packet tracer and slides.